Welcome geometry students. Today we're going to continue working with a target that states use and apply properties to solve problems with justification. The key when we hear justification is really just that you need to have the ability to explain why you're creating equations that you're creating or statements that you're making. So you need to be able to explain your work this unit. Okay, let's start with the distributive property. You're going to find today that many of the steps that we're going to be using are very familiar to you because they're related to algebra. So one thing you need to be really careful of when we're using the distributive property is to watch your signs. So if we look at this particular problem, we can't do anything inside the parentheses because they are not like terms. But what it's telling us to do, since the -6 is touching the parentheses, it's telling us to multiply the -6 with every term inside the parentheses. So we're going to multiply the -6 with a positive 2x, which makes -12x, and -6 times a -5, which make the positive 30. This is often the mistake people will make because they'll forget their double negative makes a positive. So just be very careful with that when you're using the distributive property. Okay, these are some algebraic properties that you used last year when you solved equations, but you maybe didn't identify them as a name of a property. So it says let A, B, and C be real numbers. The addition property states if A is equal to B, then A plus C is equal to B plus C. In other words, you can take an equation like A equals B and add the same amount to each side and it still has the same value. It's still a true equation. The subtraction property states if A equals B, then we can do the same thing. We can subtract the same amount, C, from both sides. So again, I started with A equals B, and I'm just taking away C from both sides. That's called the subtraction property. Multiplication property tells me that I can multiply both sides by the same quantity, and I still end up with a true equation. The division property states if A equals B and C does not equal 0, then A divided by C is the same as what we started with, and that would equal B over C. And finally, the substitution property states if A equals B, then A can be substituted in for B in any equation. Okay, we're going to use these properties in a minute to show how we can solve an equation. So in example 1, it says to write a 2-column proof. Well, if you notice, we have the first column, which is the statement. So the statement is basically just what we are writing. And then on the right side, we're going to write the reason. So you're going to be very familiar with the left side of the proof today because it's exactly what you did last year when you solved equations. The reason part you probably have not done before, so we're going to practice that. So that's probably going to be your focus today. So it says to write a 2-column proof to solve. Solve just means to find the solution or to find the value of the variable that makes that statement true. And we need to write a reason. So when you're writing a 2-column proof, this is called an algebraic proof. The first thing we're going to do is we're going to label our steps. So statement 1 is going to be the problem that was given to us. So I'm just going to write the problem identical to how it was given. My reason for that then, I label my reasons with numbers as well so that I know that statement 1 should match with reason 1, and the first reason is always going to be given. So any information that's provided to you, we're just going to simply say the reason is given. Okay, well the first step we would need to take in solving this equation is we would need to get rid of the parentheses. So we're going to use the distributive property, and that would become 2x plus 6 is equal to 9, just like we would have done in the past. The difference is, though, now we're going to supply a reason for which property we use to get to that result. Well, we said that that's the distributive property. So now we think about the next step we would take. We would go ahead and isolate the variable term. So I'm going to show -6 Some of you are probably familiar with drawing a line through your equal sign. If not, that's okay. So if I subtract 6 from the left side, that cancels out my constant terms, and I'm left with, in step 4, 2x is equal to 3. So I did my work, but I did not yet show my reasons. So what I did here is I'm basically just using the subtraction property to show that I can subtract the same amount from both sides and still be following my rules of solving an equation. So I'm just going to write subtraction property. And then here in step 4, all we did was simplify the equation. So we just write simplify. Okay, well, we're not done with our equation, so let's continue on. Now I need to get rid of the coefficient of the variable. The coefficient, reminder, is just the number in front of the variable. So I'm going to divide both sides of my equation by 2. And since I'm dividing both sides by the same amount, that's called the division property. All right, well, let's put what remains. X is equal to 3 over 2, which is the same as 1.5. And again here, all we didn't apply a new property. We just simplified what we had from the prior step. So if you notice, simplify is probably going to be about every other step, not always, but often after you have a subtraction or addition property, you're going to have a step that says simplify in your reason. All right, well, that's it for today. Go ahead and try the You Try Now and check your answers. Come with your questions as you come up with them, and we will talk about them the next time we meet. Have a great day, and I'll see you soon.